What's up, everybody? This is Alex Rothenberg here, and this is my mini lesson on Chapter 2, Precipitation. So, we all know what precipitation is, the weather outside, whether it's rain, snow, sleet, ice. But I'm going to teach you a little bit about the specifics of it. Alright, let's get started. So, what is precipitation exactly? Precipitation may be created when air rises, causing water vapor to condense in the atmosphere. The air may be forced to rise because it is heated at the Earth's surface. So, with more and more global warming going on, there's going to be more and more precipitation because the Earth's surface is going to get even more hotter. So, we talk about normal precipitation, which is what is necessary on Earth. So, when it normally rains or snows, that gives us water for the crops. But whenever there's normal precipitation, there will always be unusual precipitation. This is not good. These are tornadoes, these are hurricanes that usually do not occur but will occur once in a while. So this is what we try to stop. So there are many mechanisms of precipitation. The first one is condensation. Now, condensation is the conversion of water from vapor to the liquid state. This occurs when the saturation of the vapor pressure is less than the level of moisture in the air. So that's like the key for it to happen. Now, another mechanism is rising air, which is the movement of the air that causes precipitation to happen in three different ways. The first one is convection. The second one is orographic uplift, and the third one is frontal uplift. I will go into more detail about all three of these right now. So the first one, convectional precipitation, occurs when the air, warmer than its surroundings, rises, expands, and cools by this expansion. So there's a lot going on right there. When the air rises, it has less weight above it and allows the air to expand. So because there is less weight above the air, it has time to expand. So this creates adiabatic cooling. Now, adiabatic cooling is the decrease in temperature that results from the expansion of rising air. That's the definition of it. Adiabatic alone means without heat being involved. So pretty much this is happening without any heat involved. So the other mechanism is orographic precipitation. This happens as the air rises, it cools adiabatically, which we just talked about, and the cooling causes condensation and precipitation results. So it's similar to condensation because condensation goes into it, but it has a little more added to it. This is caused when horizontal winds move air against mountain ranges, forcing the air to rise as it passes over the mountains. So this happens a lot more in mountainous areas and more rough terrain areas than smooth areas. The third one is frontal precipitation. Now, when you hear fronts, you always think of warm fronts, cold fronts, but do we really know what that means? So forms along a front. So a front is a boundary between two air masses, either warm or cold. So yeah, they're cold or warm fronts. A cold front is when a cold air mass advances against a warmer one, and the warm front is the opposite, when a warm air mass advances against cooler air. It is very important to know the key differences between these two. And now I have some questions for you guys to answer. The first one is, on a humid day, would you expect to see clouds lower or higher in the sky than on a day of low humidity? Just think about that for a little bit. Another one is, like I said before, what is the difference between warm and cold fronts? There may be a couple, there may be none. I don't know. And third, which mechanisms does adiabatic cooling occur? Could be one of them, could be all of them, could be none of them. That's for you guys to find out. Thank you for listening to me. This is Alex Rothenberg again. See you guys next week.